So we are doing the, am I audible behind? So we are doing the interiors of the earth, that is the sources to study the interior of the earth. The first source direct में digging a hole. Prelims का question उसमें कि which is the deepest mine in the world. कहाँ पे कौन से country में है? I have given that in PPT. I will show you the PPT after we finish this sources. That is in South Africa. It is an example of an gold mine. Second direct source is meteors. So they can ask you some of the questions of the meteors. That is, are meteors, do they burn when they enter the interior of the earth? Yes. So indirect source में लिया हमने meteors. That these meteors, when they come inside the earth, they will burn and exposing the inner core. By studying the inner core, we can know that the inner core of the meteor is made up of heavy minerals, and thus we conclude that the earth ka inner core may also be made up of heavy minerals. And then we study it with the help of seismic waves, and we will see the velocity of the seismic waves, and we will see, yes, the densest part is that of an core. One of the other important sources is volcanism. The part from where magma comes on the surface of the earth is just 200 kilometers deep. Maximum depth is somewhere around 400 kilometers. So this source of magma or lava is the zone of weak rocks. अभी क्यों है weak rocks? कल एक indirect source पढ़ा. That is, as we go inside, the temperature goes on increasing. Pressure also goes on increasing. जितना आप deep जाओगे, temperature increase होगा, pressure will increase. But in the top 200 kilometers, when we have not gone that deep, temperature increase is more dominant than the increase of pressure. And because the temperature increase is more dominant, temperature क्योंकि ज़्यादा है, the rocks are not in the solid state. The rocks are in a jelly-like state or not in a liquid state. Remember, jelly-like state. In a molten state, but not in a liquid state. Liquid state and a molten jelly-like state is two different things. So when they are in a jelly-like state, this becomes the source of magma or lava, and we call this as a zone of weak area. Weak matlab in Greek language asthen, and sphere matlab area, and therefore this zone of weak rocks is known as an asthenosphere. आगे जाके we'll see that asthenosphere is the place where the continents or the sea floor is not spreading. What is moving is the plates, and the plates will slide across the over the asthenosphere because it is in the semi-molten or the jelly-like substance. इसलिए magma or lava comes out from this asthenosphere. Then the next source that we study is the temperature pressure. I guess we have written that both the temperature and pressure increases as we go inside the earth. And the most important source which we study for the interior of the earth are seismic waves. Now, what are these seismic waves? These are the waves that are generated during the earthquake. Why are the earthquakes caused? Or what do you mean by earthquake? Displacement of what? Tectonic plates. उसके बाद एक ही रीजन है अर्थक्वेक का, सिर्फ प्लेट टेक्टोनिक है रीजन अर्थक्वेक का. Why sudden release of energy? Convergence, divergence, कन्वेक्शनल करंट्स कैसे अर्थक्वेक्स करेंगे? So that causes the movement of the plates. Convectional currents will cause the movement of the plates. What is an earthquake? अगर मैंने आपको सिंपल लैंग्वेज में पूछा what is an earthquake? So what is an earthquake? Shaking of the earth. अभी आपको ये बताना है why does the earth shakes? Can I say the shaking of the earth will occur because of plate tectonics, plate movements? Can I say the shaking of the earthquake may occur due to volcanic eruptions? Volcano eruptions, volcano magma will travel inside the earth, displacing or disturbing the equilibrium. Suppose ये gap है, ये एक बड़ा rock surface है, and this is another big rock surface, and इसके ऊपर there is a sedimentary layer, and इसके ऊपर we are staying. Now the magma, when it is coming out with a great speed or with great velocity, it will displace this gap and as a result it may cause the shaking of the earthquake. So one of the reason of the earthquake is the volcanic activity. Does nuclear explosion causes earthquakes? Yes. Does tsunami causes earthquakes? Does earthquake cause tsunami? Or tsunami causes earthquakes? Earthquakes cause tsunami, and the tsunami may also cause the earthquakes, that is the shaking of the earth. Or can I say meteor impact, earthquake? So remember one simple thing, that is don't go only by technical things ki earthquake matlab sirf plate tectonics. Plate tectonics is only one reason for an earthquake. There are numerous other reasons for an earthquake. For example, Government of India has stopped constructing big dams, especially in the Himalayan regions. Tehri ke baad, we have stopped constructing big dams. Brahmaputra, Arunachal Pradesh, हम आगे पढ़ेंगे. It is the state which is having the highest hydroelectric power potential. But still, there is no construction of big dams in the Arunachal Pradesh. उसका reason is because big dams cause large-scale earthquakes. जितना हिमालयास तो यंग है, बहुत यंग है, मीन्स दे विल कीप ऑन कंटिन्यूसली बीइंग uplifted and shaking. The oldest landmass in the world, peninsular plateau, वहाँ पे human beings ने dams बनाए and it has resulted into the large scale earthquakes. So what will happen if we make the entire Himalayas full of dams, that the entire north plains will get destroyed because of an earthquakes. So you should know in simple words why the earthquakes are generated. The earthquakes are generated due to the release of energy. This is a shaking of the earth and causes release of energy. It causes the release of energy. Now, how is this energy released? This energy is released in the form of waves, and we call this as an seismic waves. Now, where are these seismic waves generated? Some of the seismic waves are generated inside the earth, and we will call them as an body waves. Some of the seismic waves are generated outside the earth, and we will call them as an surface waves. So there are body waves generated inside the earth, and they travel through inside the earth. And the surface waves, they travel on the surface of the earth. So if we consider this as the earth, there are some waves which are generated inside the earth, and we'll call them as, this is inside the earth, so we'll call them as body waves. And there are some of the waves which are generated on the top of the earth. They travel on the surface where we are staying, and we will call them as the surface waves. So this is a diagram of an surface waves. Now, before we go to the seismic waves, there are 2 points which we should know in the earthquake. Is one, this point, which is located always inside the earth. What you will call this? And उसके ऊपर एक point होता है. This is always on the surface of the earth. So this inside point is known as focus, or it is known as an hypocenter. Always inside the earth. And it is a point where the earthquake waves are generated. Are generated. Which waves? The body waves are generated. And this is what is known as an epicenter. Always on the surface of the earth, and it is the point which is at a perpendicular distance nearest to the focus or nearest to the hypocenter. It is always on the surface of the earth, nearest to, and it is the nearest point to the focus. It is a point where the waves will first be recorded. It's the point, sorry, not recorded, it's a point on the surface जहाँ पे the earthquake का maximum impact will be seen. So this epicenter, as of now, you remember, it is always on the surface. Nearest to the focus. ये पार्ट थोड़ा टेक्निकल है. So now the body waves which are there, depending upon उनका speed, depending upon उनका property, are of two types. Body waves जो अंदर से पास हो रही है. We are living at the surface, so body waves are passing through the inside, and this body waves, depending upon उनका speed, are further classified into P waves, that is the primary waves, and S waves, that is the secondary waves. Now why primary wave and why, or P wave, why secondary wave? उसके बाद there are other waves that are known as surface waves. Surface waves are generated due to the interaction of primary wave and secondary wave with the surface rocks. When the surface rocks में both the P wave and S wave will interact, surface rocks will be compressed or released. जब भी कोई compress होता है, जब आप rubber band खींचते हो and suddenly the rubber band breaks and it comes back to its original position, तो यहाँ पे does it hit you? Yes. Why? Because it releases large amount of energy. So similarly, when the P waves and S waves will interact or with the surface rocks, they will release large kind of energy, and that energy is what is known as an surface waves. But which topic we are studying? We are studying in the topic of interior of the earth. And interior of the earth के लिए हमारे लिए which waves are important? Body waves. That is the, not the surface waves. So now why the primary wave? Primary wave, because if you are standing here on the surface, the first wave you will record on an instrument known as seismograph is the primary wave. Not because it is the first wave to be generated, it is the first wave to be recorded on an instrument, when therefore we will call this as a primary wave. Why secondary wave? Because it is the second wave to be recorded. Now why is it a second wave to be recorded? Because the primary wave travels with double the speed of a secondary wave, or secondary wave travels with half the speed of a primary wave. And as a result of this, the first wave to be recorded is in primary, then secondary, and then comes the surface waves. How is it applied in our daily life? Whenever the earthquake comes, पहले shaking होता है या पहले एक slight tremor आता है, slight shaking, या बहुत disastrous shaking होता है? There is a slight shaking, what you will call it as a tremor. जैसे ही tremor आता है, you are expected to come out of the building, या go below the tables, या go below the wall का beams, क्योंकि whenever there is an earthquake, क्या नहीं गिरेगा generally building का is the structural skeleton of an building, जो स्टील से बनाए, जो रीइंफोर्स स्टील से बनाए या जो लोहे से बनाए, बाकी तो सब गिर जाएगा. सो रीइंफोर्स स्टील से क्या बनाए? दिस बीम इज देयर व्हिच इज गोइंग ऑन एंड इट इज मेड अप ऑफ प्योर कंक्रीट एंड स्टील. सो ये गिरने के चांसेस बहुत कम है, बट बाकी सब ये गिर जाएगा. ऑल दिस व्हाट नहीं गिरेगा इज दिस द, because this is where the beam is going, and therefore you see color differences are there. So anywhere in the houses also you can see beam is untouched. चाहे वो हॉल आपने बड़ा किया, चाहे ये रूम हमने चेंज किया, what we have not done is we have not touched the beam. You can go in the next, we had a class in the next classroom that day. उसमें बीच में pillars है. Why? Because if we touch the pillars to make sure that कहीं से भी board दिखेगा, तो क्या होगा? In case an earthquake or in case of any natural disaster, there will be the chance of entire building coming down. So this is what the tremor is. Tremor is the primary wave. Is it very strong or is it very light? It is very light. So if you are a person who is here The first wave which we will see, जो सबसे ज़्यादा speed से आता है, that is an example of an primary wave. And it is recorded like this in a seismograph. That means it does not have that much destruction potential. It will just shake a fan little bit, or it will just shake a building little bit. If the tremor is not strong, you don't even realize. You see that क्या होता है, we see that the न्यूज़पेपर में आप पढ़ते हो कि दिल्ली में XYZ अमाउंट ऑफ ट्रेमर केम, एंड उसके बाद यू सी कि अरे मैं तो सब सोया था, मुझे रियलाइज भी नहीं हुआ. ऐसे बहुत बार यू मस्ट हैव सीन. मनु क्या हुआ? Then after that, the next wave to come on the surface of the earth is an S wave. And this is जो आपको अगर रात को जनरली अर्थक्वेक आता है तो ये आपको नींद से उठा देगा. That is the S waves. उसके बाद भी अगर आप सोते हो, आलसी हो, then the next wave is the surface wave, which will then has a very high destructive potential. So this is what is the waves, how they come on the surface of the earth. P wave, S wave and the surface wave. P wave in the form of tremors. Second tremor, the S wave. P wave जब आता है तो generally the building or the cot or the fan will shake in this manner. When the S wave comes, generally the buildings or any object will shake in up and down manner. And when the surface wave comes, because it is a combination of all the waves, P waves and S waves, usme there is both the movement, this way and up and down movement. And ultimately, when the buildings shake this way, as well as when the buildings are compressed and released, as well as they shake up and down, they will ultimately fall. And as a result of this, surface wave is the most dangerous. But one good thing is, not all the places in the world will experience surface waves. There will be tremors, but they will not experience the surface waves. Why? Because both P wave and S waves will not interact with the rocks, and because they do not interact with the rocks, surface waves are not generated. So we have seen in many of the places कि दिल्ली में tremor आता है, South दिल्ली में नहीं होता है. Yeah, one part of Delhi has tremor, the other part of Delhi does not have tremor. That depends because of the interaction of the surface rocks. That depends upon the direction of the wave propagation. Sometimes there is a very powerful earthquake in Afghanistan, and the same powerful earthquake, epicenter is in Afghanistan or the focus is in Afghanistan. It will cause a problem in Haryana. It will cause a problem in Punjab, but it may not cause a problem, that much problem in Himachal Pradesh. Why? Because rocks ka property hai that which waves are to be generated or not. For the rock waves to be generated, both the waves, for the surface wave to be generated, both the waves should interact. And then once the earthquake comes, there can be death and destruction. अब you should understand, जहाँ जहाँ fold mountains है world में, उसके आसपास का regions are always prone to earthquakes. So zone 5 in India, which is the high risk zone, is the entire Himalayas. We right now are in the zone 4 of an earthquake, and even this is very very high risk zone in the terms of an earthquakes. And earthquakes के साथ problems है that do earthquakes kill the people? What is the difference between natural hazard and natural disaster? What is the difference between, I can say earthquake is a natural hazard or I can say earthquake is a natural disaster? क्या है difference? It is a disaster. Why not hazard? Hazard is nature में there is always a hazard. Earthquake is an hazard, cyclone is an hazard, etc. And disaster is mostly in the developing nations. Because disaster matlab that hazard, if it causes death and destruction, it becomes a disaster. If it does not causes large scale death and destruction, it becomes an hazard. So earthquake agar aata hai in Japan, It generally is a natural hazard rather than a natural disaster, unless it is a very, very powerful earthquake. But if it comes in a developing country like India, it becomes a disaster because it kills large amount of people. Why is it so? Because earthquakes या कोई भी natural hazards do not kill the people. It is the human's response which is going to kill. It is the buildings which kill the people, not the earthquakes. Yes, tsunami becomes a natural disaster because उसमें कोई फर्क नहीं पड़ेगा फिर, whether you have a building or not, because the waves will come at the height of somewhere around 30 to 35 meters. 30 to 35 meters मतलब 100 feet के आसपास की height of the waves है, with the speed of 600 to 700 kilometers per hour. And if such a waves is coming with a great speed, obviously फिर कुछ नहीं बचेगा. So you should know that is the basic difference between hazard and disaster. So right now, if right now the earthquake comes, consider you are sitting here, right now the earthquake comes, it will not cause large scale disaster because these buildings जो है, they are commercial properties. And commercial properties के जो buildings है, there are some specific ratios or some specific designs कि सीढ़ियाँ, there should be quick management of the resources. There should be the fire extinguisher in each and every room. Most of the rooms should have 2 doors. यहाँ पे तो how we then comply in India, how the laws are compliant in India. You can see door भी है और ये classroom भी है. And but this is the new door. But if you see the proper compliant, यहाँ पे 2 doors होने चाहिए थे. सीढ़ियाँ यहाँ पे proper है. Now imagine some of the buildings are there. You will find very, very less such buildings in Rajendra Nagar, but you will find many such buildings in Mukherjee Nagar, which have now been sealed by the Supreme Court order. Why is it so? Because if in case there is an earthquake, people will panic and they will not die because of tremors. They will die because of stampede. इतनी छोटी उसकी सीढ़ियाँ, and they are vertically coming down, not properly coming down. And you will find that in the unregulated colonies in Delhi. You will find, therefore, what the Supreme Court did. Supreme Court said compulsory sealing drive. So, because if you are unaware, most of the classes in the Rajendra Nagar market have been sealed. Most of the libraries in the Rajendra Nagar market have been sealed, especially libraries जो basement में थी. Why? Because in case there is a fire, in case there is an earthquake, or in case there can be anything, any hazard, any hazard, then ultimately there can be death. Because if there is in the basement, you get trapped in the basement. And remember, Delhi is highly prone to earthquakes. Why? Because we are very, very near to the Himalayas. And what is happening in the Himalayas? Plate tectonics. In the Himalayas, the 2 plates, Indian plate is colliding with the Eurasian plate. And उसमें Indian plate is already moving to the north. So जब भी Indian plate moves to the north, there is an chances of an earthquakes in Delhi. हर 8 minute बाद there is a possibility of tremor in Delhi, but thankfully the tremors are not that strong. But हर 3 minute बाद there are very, very strong tremors in Japan. So Japan में after every 3 minutes there is an earthquake. But what do we see? A very large scale earthquake, 8.2 on the Richter scale or 7 on the Richter scale, 20 people died. Or imagine the 7 का Richter scale का earthquake in India, what will be the headline? 230, 240 people died. So that is the difference. What do we see? Bullet train का accident in France, Germany, USA, 5 people died. हमारे इंडिया में रेलवे ब्रिज कोलैप्स होता है एंड मोर देन 100 पीपल डाई. सो यू शुड नो कि इट इज़ मोर फॉर द डेवलपिंग नेशंस. व्हाई? डेवलपिंग नेशंस पॉपुलेशन इतना ज़्यादा है और जो कमोडिटी ज़्यादा अवेलेबल है उसका हमेशा इम्पॉर्टेंस कम रहता है. सो देयर इज सो मच ऑफ एन ह्यूमन रिसोर्स जो हम कहते हैं, बट वी विल से देयर इज सो मच ऑफ एन ह्यूमन पॉपुलेशन कि कोई ज़्यादा फर्क नहीं पड़ता बिकॉज सप्लाई चेन शुरू है पीछे से. सो इफ देयर इज एन रिमूवल ऑफ द सम ऑफ द पॉपुलेशन, उससे कोई फर्क नहीं पड़ेगा. सो एज अ रिजल्ट ऑफ दिस we'll see कि government of India has now over the period of time you have this topic in the paper 3 of your syllabus. Now how we are going to study? Not from the earthquakes, we are going to study that from the landslides, because earthquakes में Indian geography में will again do in detail. That is कोई भी एक disaster and disaster management in India. Disasters, earthquakes पे question आएगा paper 1. डिजास्टर मैनेजमेंट पे स्पेसिफिकली क्वेश्चन आएगा इन द पेपर 3. फ्लड्स पे क्वेश्चन आएगा इन द पेपर 1 as well as in the paper 3. The only thing is language of the questions will be different. Causes, how to solve this in paper 1. Disaster management during floods, cyclones, tsunamis, etc. in the paper 3. But sometimes they ask you even in the paper 1, just like last year. They asked you a tsunami and tsunami disaster management ka question in the paper 1 itself in the last year. Yes, we will do now. When are these seismic waves? Surface. Sift rocks. What happens is there are two kinds of waves. One is the body wave and the surface waves. The body waves are of two types. Suppose this is the first wave to be generated, and we will call this as an primary wave or the P wave. Then at the same time there is a second wave that is generated, that is an S wave. But there are some points on the earth jahan pe S waves cannot pass, while there are some other points on the earth where the S waves can pass. When this P wave, blue color ka, and S wave, red color ka, come on the surface of the earth, they interact with the surface rocks. And when they interact with the surface rocks, they will give out another kind of the waves, that is the surface waves. So basically there are three types of waves, body waves of two types and surface wave of one type. अगर यही optional है तो there are four types of waves, two types of body waves and two types of surface waves. But that is not required in GS. What are the two types of the surface waves? L waves and Rayleigh waves, R waves or love waves. So these are the two types of waves, but वो हम detail में नहीं करते in the general studies. So seismic waves generated during the earthquake. Any doubts here? Two types of seismic waves. One is the P wave, primary wave, that is body wave, and the surface wave. Can I say the body wave travel through the interior of the earth and the surface waves on the surface? The body waves are further divided into two waves based on the property. That is the primary wave and the secondary wave. So fine with this? I guess you have written till here, जो board में था. So take down some of the statements. The speed, direction, and the interaction of the body waves are the best sources to study the layered structure of the interior of the earth. Are the best sources to study the layered structure of the interior of the earth. यही क्वेश्चन हो सकता है why the P waves or why the body waves or why the seismic waves are the best sources to study the interior of the earth. क्योंकि अभी तक हमने जो देखा that the interior of the earth में we know temperature increase हो रहा है, pressure increase हो रहा है, but exactly कहाँ से हो रहा है we do not know. Exactly asthenosphere का कितना depth है अभी तक तो sources से पता नहीं चला. But now we know that 200 kilometers है. Why? Because of the P waves and the S waves. So before we see how it does, write the properties of the P wave. Properties of the P wave. Primary waves are the first waves. Primary waves are the first waves to be recorded on seismograph, on seismograph. What is seismograph? Instrument that measures the shaking or the release of energy. जैसे you must have seen ECG machine. The same like this is the seismograph. कितना vibration हो रहा है, that is recorded. Next property of an P wave, second property. They are similar to the sound waves. They are similar to sound waves. They are similar to sound waves, which means they can travel through all the three mediums. They can travel through all the three mediums. All the three mediums. कौन से all the three mediums? That is the solid, liquid and gaseous. Does the sound wave travel through gas? Yes. आप मुझे अभी सुन रहे हो because the sound wave is traveling through the gaseous medium also. That is it can travel through the solid, liquid and gaseous medium. But what is the next property of sound wave? कि जितना greater is the density, उतना greater is the speed. जितना lesser is the density, उतना lesser is the speed. That is, suppose if we were sitting inside this and ये पूरा solid होता, we would have heard more quickly in an instant manner. अब थोड़ा there is a time lag, but we have got adjusted to the time lag, इसलिए हमें realize नहीं होता वो. So, but remember sound wave का property is sound will travel greater in the denser medium. So there has been one prelims का question also, iron, wood, air, water. So arrange this speed of a sound wave with the decreasing velocity. सबसे ज़्यादा किस में? Iron में, उसके बाद wood में, उसके बाद water में और उसके बाद air में. So this is how the sound waves will travel. The speed will be greater, but water में problem is it cannot pierce, and therefore long distance तक hear नहीं होता. In fact, air में भी it cannot pierce, इसलिए हमें speakers use करने पड़ते हैं, so that it can go through the different, and speakers में हमेशा wiring होती है. So this is an wiring, solid medium, copper wire, and then it will use in the rooms. So this is one of the property of a sound wave. The same property of a sound wave हमें earth में बताएगी, P wave की. If the P wave की speed is recorded with the help of seismograph, computer modeling etc. is done, and then we say कि XYZ core में XYZ speed है, mantle में XYZ speed है, crust में इतनी speed है, crust में भी upper crust में इतनी speed है, lower crust में इतनी speed है, and therefore can I say we can conclude about the density, or then we say the पुराने लोगों का views is that Sial and Sima. So आज हमने देखा कि continental crust में the speed is lesser than the oceanic crust. That means their views were right, and thus were ticket. Then we say कि core में there is reduction of the speed. Then we say कि reduction of the speed मतलब उसमें नीफे layer है या नहीं है, we do not understand that. So core में there is some anomaly which is happening. In some parts of the core speed इतनी कम reduce होती है that the people got confused कि core किससे बना है, whether it is denser or not denser. अभी तक तो हमने पढ़ा कि core is very very dense. So with this you take down the speed of a P waves. The speed of a P waves is greater in the denser medium, in the denser medium. Next point, P waves undergo compression and rarefaction. P waves undergo compression and rarefaction. They undergo compression and rarefaction. Now what do you mean by compression and rarefaction is, if this is how the P wave is traveling, so इसमें whatever the particles that is there, it will be stretched. अगर ये particle है तो it will be stretched. After some time it will be squeezed. After that the particle will be stretched and again it will be squeezed over the period of time. So you should remember that there will be stretching and squeezing of the particles. So that is what I said कि buildings अगर है तो initially there will be stretched and then there will be squeezed. So can I say compression and rarefaction? So they will, in simple words, you can take down in other words, they will stretch and squeeze. They will stretch and squeeze. They will stretch and squeeze the particles, causing deformation of a rock, causing deformation of rocks, causing deformation of rocks. You only tell me, कैसे? Perpendicular to the direction of wave propagation या parallel to the direction of wave propagation? Deformation of rocks. अगर rocks है, if this is the direction of wave propagation, तो इसमें the particles are moving parallel to the direction of wave propagation या perpendicular to the direction of wave propagation? अगर ये rock है, तो it will be stretched, it will be squeezed. It will be stretched, it will be squeezed. So जो rock है वो ऐसे हिलेगा, parallel है, and बाकी perpendicular means rock ऐसे हिलेगा. So what is happening here? Parallel, resulting into what I said? Deformation of the particles, where deformation of the rocks, where rocks move parallel to the direction of wave propagation. Parallel to the direction of wave propagation. Next, P waves are fastest. P waves are fastest, but of least intensity. Then S waves. Travel with half the speed of P wave. They travel with half the speed of P waves. They travel with half the speed of P waves. And therefore, they are the second waves to be recorded on a seismograph. Second waves to be recorded on a seismograph. इसलिए हम नाम क्या कहते हैं इसको? Secondary waves. Now see, if this is an S wave which is going in this region, in the S waves, the particles जो है, if this is a particle, rock, stationary, या building, या anything, particle, it will move up, it will move down. It will move up and it will move down. So can I say S waves cause displacement perpendicular to the direction of wave propagation? P waves में क्या होता? They would have stretched and squeezed. Stretched and squeezed. यहाँ पे ऊपर नीचे. So you understand why P wave जब आती है तो पंखा ऐसे होता है. And जब P wave, S wave आती है तो पंखा गिरने का चांस ज़्यादा होता है. Why? Because it will be going up and down. P wave in the parallel direction. S waves up and down. So the next thing that is In the S waves, the particles move up and down. The particles move up and down. That is perpendicular to the direction of wave propagation. Perpendicular to the direction of wave propagation. Perpendicular to the direction of wave propagation. Have you written that? Yes. The next point is, this is the most important point, is the S waves can pass only through solids. The S waves can pass only through solids. S waves can pass only through solids. That means it will not pass through liquid and gaseous medium. So ये बताएगा कि interior of the earth is gaseous also, or is there any liquid in that, or is it only solid? जहाँ जहाँ S waves are not recorded or it cannot pass, इसका मतलब क्या है? That is, वहाँ पे the earth is in liquid nature. Can earth be gaseous inside? Why? It can be कि जहाँ the S waves are not recorded, it can mean two things. That is, either the earth is liquid or either gaseous. But you have to understand one logical thing, कि at such a high temperature, gaseous medium, high temperature and pressure, gas cannot exist. It will be mostly in the liquid form. जैसे आप नीचे जाते हो तो गैस का existence बहुत कम है. Why? Because the temperature के साथ साथ pressure is also increasing. Now, how they help in studying the interior of the earth? First is direction. First is direction. Suppose if this is in focus, and यहाँ से if the wave is generated, if the wave travels in, don't write anything, understand, if the wave travels in the manner A versus if the wave travels in the manner B, what you can conclude if it travels in manner A versus manner B? A means, can I say it is traveling in the straight line inside the interior of the earth? You have to imagine ये सब कहाँ हो रहा है? In the interior of the earth. It is traveling in a straight line inside the interior of the earth. And can I say it is traveling in a curved manner inside the interior of the earth? A वाला situation कभी नहीं होगा. हमेशा the waves will travel in a curved manner. Before I go, any students here with humanities background? या सारों का background science है? So, are you getting this? Because ये तो geography का start है सिर्फ. Geography is nothing but a science. थोड़ा initial part. That is, if you have any doubts, you can ask me here. Because ये तो फिर भी easy है. क्लाइमेटोलॉजी में थोड़ा बहुत ज़्यादा यूज़ होता है टेम्परेचर एंड प्रेशर, बट वी डू नॉट गो दैट मच इनटू डिटेल हियर. सो ओनली दिस पार्ट जो है, जो टेक्निकल पार्ट्स है, दिस आर द थोड़ा दे यूज दिस मेथड ऑफ साइंस, बट वही बेसिक साइंस जो विच एनीवेज यू शुड नो. व्हाट इज दिस बेसिक साइंस? कि बिकॉज द waves do not travel in a straight line, they travel in a curved path. So can I say, or can we conclude that the earth is made up of materials of different densities? And because it is made up of materials of different densities, so the waves undergo refraction or bending of the path. So ये हमें पता लगता है with the help of P waves and S waves. अभी तक हमें सियाल सीमा में पता नहीं लगा सिलिका एंड एल्यूमिनियम, बट क्या पूरा अर्थ इज मेड अप ऑफ सिलिका एंड एल्यूमिनियम? नो. It is made up of the rocks which are dominant in some extent, silica and aluminum, but इसका मतलब है earth is made up of the rocks which are molten form of different densities. And the same thing is seen on the surface of the earth. So you understand, because of density differences, why there is a difference of density? Because minerals are different. And because the minerals are different, इसीलिए कुछ जगह black है color of the soil, कुछ जगह red is the color of the soil, in some parts yellow is the color of the soil, in some parts brown is the color of the soil. It depends upon what minerals are present. If there is ores of magnetite, black. If there are iron oxides, red. If there is more of an limestone, yellowish in color. If there is an equal amount of limestone, calcium, iron, then brownish in color. If there is no human substance or there is no dead and decomposed matter, then it is yellowish in color. So the same, because different minerals are there, isliye we have different types of soils. Because there is a different types of soils, isliye we have different types of crops. And because there are different types of crops, therefore we can survive, because our body requires different kinds of nutrition. ये है nature का काम. Remember, nature gives you everything you need as per the seasons. But उसके लिए you will have to go to bazaar, not to the supermarkets. Why? Because supermarkets have processed foods. Supermarkets have refrigerated foods. Apple 12 महीने मिलेगा. Watermelon 12 महीने मिलेगा in supermarkets. Nature will give you watermelon only when there is greater dehydration. That is the month of dry summers. But nature उसके बाद, when there is an hot summer season, nature will give you mangoes. Why? Because sugar level in your body drastically decreases with high temperature, and you eat mango and there is an sugar level again. But mango ही खाओगे तो diabetes हो सकता है, इसलिए nature gives you jamun also during that season. So this is what is you can understand biodiversity, or how the nature has planned. Yes, Karela is also there. So this is how the nature gives you. Why is this? Because each and every crop ka requirement is different. Example, you must be knowing something known as a Darjeeling tea. क्या है Darjeeling tea की खासियत? कभी पी के देखिए Darjeeling tea? It is a tasteless tea, but very high demand in the international market. It is exported. It is one of the most costliest tea in the world, Darjeeling tea. Why it is tasteless? Because the taste of our Indians is दूध में चाय पत्ती. But if you take it without milk, which we do not like, then without milk it is a very good tea. So I am asking you whether it is a green tea or black tea. Darjeeling tea is an example of a black tea. जो हमारा नॉर्मल चाय भी है, ब्लैक टी. अब नॉर्मल ब्लैक टी को पानी में पियो बहुत कड़वा लगेगा, बट द दार्जिलिंग टी विल टेस्ट डिफरेंटली. पुट दूध in the normal tea, you are drinking it and you like it with, and if you go to the some of the states like Rajasthan, Maharashtra, etc., वहाँ पे तो पूरा मसाला बनता है चाय का, and then the चाय में डाला जाता है. So, but if you go to the Western countries, they do not have with milk, so they like the Darjeeling tea. अब ये Darjeeling tea की खासियत क्यों है? कि WTO gives it a geographical indication. It is why it is a special kind of an black tea, because the Darjeeling ka soil has more of an potassium as compared to any other soil in the world, and potassium just changes the taste of a tea. Now why it has more potassium? It has more potassium because of the presence of the Himalayas. You must be knowing something known as senda namak versus the common salt. Now what is this common salt? Sodium chloride, right? And why senda namak? That is what is known as an Himalayan pink salt. What is the difference between the senda namak and the common salt? Ki in the senda namak, along with the sodium, you have magnesium, you have potassium. So on the days of fast, when you don't eat anything, they advise you to have senda namak so that you can get excess of magnesium and the potassium other than the sodium also. So over the period of time, और ये कहाँ पे मिलता है this salt? This is found only जहाँ पे Himalayas है. Nowhere in the world you will find that pink color का salt except in the Himalayan region. So This is on the surface. The same thing happens below the earth also, where we cannot go. But it tells us the direction of the propagation of the P waves and the S waves, they do not travel in the straight line. It tells us that the earth is made up of the materials of different densities. Now you know what is the law of refraction? Refraction is the bending. Can I say if there is a very great change in the medium, from one medium to another, there will be sudden bend? So we also see that the P waves or the waves which are there, after they originate, they experience a sudden bend at some position, then they experience a sudden bend, and then they experience a sudden bend. Then we can conclude maybe bend hai crust mantle boundary, maybe another bend is mantle core boundary, or फिर से वो core में से they are coming to mantle and to the crust, and thus there is an more or more bend. With this bend, density भी change हो रही है, and with the density speed is changing, and with the speed being changing, अब हमें पता है at 2,900 kilometer is XYZ discontinuity. What we call it as an Gutenberg discontinuity. At 30 kilometers, we have Mohovoric discontinuity. What do you mean by Moho discontinuity? Means boundary. So crust mantle boundary kahan pe hai, mantle core boundary kahan pe hai. How do we know? We know it with the help of change in the direction and the change in the speed of the seismic waves. इससे पहले नहीं पता था. इससे पहले we were just studying the meteors. अब meteors को study करके can you tell inside the earth कहाँ पे mantle core boundary है? Exactly no. अब हमें पता है that at 200 kilometers below the earth, between the zone between 30 to 200 kilometers below the earth, there is decrease in the velocity of an waves, and therefore we call it as an asthenosphere, jelly-like substance, which is present. So one is direction. So you can take down the change in the direction. The change in the direction, the change in the direction and the velocity, is due to the changes in the densities of the medium through which P and S waves pass. Of medium through which the P and the S waves pass. Thus the refraction, thus the waves undergo refraction, while passing through the interior of the earth. Passing through the interior of the earth. Next point. डायरेक्शन चेंज करके कैसे वो स्ट्रेट में जाएगा? इसी को तो हम रिफ्रैक्शन कहेंगे ना. ये पूरी मैंने स्टोरी बताई अभी. यू आर आस्किंग दैट कैसे स्ट्रेट होगा? सी अंडरस्टैंड, चेंज ऑफ डायरेक्शन. वैसे छोटे छोटे पॉइंट पे डायरेक्शन चेंज करेंगे, वी कैन से दैट इट बिकम्स मोर और लेस कर्व. हाउ यू कैन से कि यहाँ से ओरिजिनेट होकर एग्जैक्टली स्ट्रेट जाएगी? स्ट्रेट तभी जाएगी इफ दिस एंटायर इज मेड अप ऑफ सेम डेंसिटी. स्ट्रेट यहाँ से तभी जाएगी इफ दिस एंटायर पार्ट इज मेड अप ऑफ स्ट्रेट डेंसिटी, बट द डेंसिटी इज कीपिंग ऑन चेंजिंग, सो ऑब्वियसली द डायरेक्शन इज कीपिंग ऑन चेंजिंग. Any other doubts? Asthenosphere is solid. It is not liquid. It is jelly-like substance. Now, if I ask you, Alpenlibe and fruity mein what is the difference? So what is Alpenlibe? Solid you will call jelly, jelly like substance, but it is more or less like a solid only, and fruity is liquid. So that is the difference. Alpenlibe, remember asthenosphere. Okay. Next point, there is sudden bend, and change of velocity. There is sudden bend and the change of velocity. Sudden bend and the change of velocity when the waves move from crust to mantle, and from mantle to core. Mantle to core. This boundaries of crust mantle and mantle core are known as Moho discontinuity and Gutenberg discontinuity respectively. Moho discontinuity and the Gutenberg discontinuity respectively. Moho discontinuity and the Gutenberg discontinuity respectively. Matlab Moho discontinuity is between the crust and the mantle, and Gutenberg is between the mantle and the core. Mantle and the core. Can I rub this part? Before we go to the next point, understand this very properly. I'll take this part as a crust, the uppermost layer as a crust here. Again the interior of the earth. उसके बाद we will consider this as a mantle, बीच में का layer, and the innermost layer as a core. We will consider the blue wave as a P wave. The P wave may be generated here somewhere जहाँ पे focus है, and then this is how the P wave will travel. As it is going inside, speed is being recorded. How it is recorded, you don't worry about that, but the speed is being recorded in the crust. Now when it is traveling here, imagine an hypothetical situation कि वहाँ पे the speed is 3.5 meters per second. Actually, in reality, it can be 3.5 kilometers per second. It can be 3.5 kilometers per second के आसपास, but you just remember that it is around 3.5 meters per second. After that, वो जब नीचे आता है in the crust, we experience the speed of a P wave to go to somewhere around 5 meters per second. After that, when it crosses this dotted line, there is a sudden increase in the speed. but this increase in the speed also tells us what कि ये है what this dotted line is boundary between mantle crust and the mantle. क्यों speed increase हो रहा है and refraction is increasing. और फिर ये mathematical calculation करके it was found out by Russian scientist known as Rushikesh, and therefore we call it as a Moho discontinuity. When it comes inside, again there is slight increase in the speed of an P wave, but there is also increase in the refraction. When there is a slight increase in the speed of an P wave, after 200 kilometers, maybe यहाँ पे slight increase है, 5.1 meters per second. ये values याद रखने की ज़रूरत नहीं है. This is just for your understanding. But after 200 kilometers, this 5.1 may become somewhere around 7 meters per second. That means scientist को अभी आपको क्या पता लग रहा है कि 200 किलोमीटर के बाद what has increased is the density has increased because the speed has increased. And then when it is traveling in this manner, फिर से we will see opposite is happening. That is, यहाँ पे फिर से speed is decreasing and the speed is decreasing. Now you consider another P wave which is traveling here. It will also behave in the same manner. क्या होगा? Speed will increase, refraction will increase, speed increase होगा और उसके बाद 200 किलोमीटर के बाद again the speed will increase. Speed बहुत ज़्यादा हो जाएगा inside the after 700 kilometers and it will become somewhere around 9 meters per second. Then it will again decrease and further it will decrease and then it is recorded time gap कितना हुआ. But there is another P wave which is starting from here. It will pass through this, speed increase होगा, there will be sudden increase in the speed. And then when it comes here, there is a large scale refraction. When there is a large scale refraction, हमें पता लगता है that it is crossed some other boundary. और ये boundary मिला at 2,900 kilometers and it was discovered by Gutenberg and we call this as an Gutenberg discontinuity. And surprisingly, देखो पुराने understanding है कि core is made up of denser materials etc. Surprisingly, what the scientists found that यहाँ पे the speed kept on decreasing and यहाँ पे the speed became again somewhere near 5 meters per second or somewhere around 4 meters per second. अभी तक हमारे अंडरस्टैंडिंग से यहाँ पे the speed should become very very high, but it is decreasing. And then after 5,100 kilometers, there is sudden increase in the speed and it becomes 15 meters per second. Again when it comes here, there is decrease in the speed, but एक बार वो यहाँ पे आता है तो what happens? There is again increase in the speed. So another P wave, one P wave is here, it will behave in the same manner. There is another P wave, it will behave in the same manner. There is third P wave here, there is behaving in the same manner. And उससे हमें पता लगता है how the direction keeps on changing. But this P wave behaves in a very different manner. कि इतना ज़्यादा रिफ्रैक्शन क्यों हो रहा है, people did not understood and they also did not understood कि if this is an P wave वो इसको टच करके जा रहा है, but after this region due to refraction there were certain places on the earth जहाँ पे the P wave was not at all recorded. Can I say why in my diagram here why the P wave is not recorded? Because of large scale refraction. And जहाँ पे this P wave was not recorded, it was known as an shadow zone. Why it was not recorded? Very easily understood, because refraction बहुत ज़्यादा है. Why refraction is very greater? Because Sial Sima, दोनों में silica is common, but जैसे you come to the mantle, the material totally changes and the density changes and therefore refraction is very very great. But after that they started studying the S waves, but we did not understand one problem here कि यहाँ पे why the speed decreases. Getting it? Why the speed decreases? Then, while studying the S waves also behaved in a same manner. That is, यहाँ पे it went similar to the direction of an P wave, but exactly with the half of speed. So यहाँ पे I'll take the speed is half of that of an P waves. यहाँ पे the speed is half of that of an P waves. So it followed the same direction of an P wave, but there was the change of the speed was in half. So it started going in this direction again. Then it started going again in this direction, but it went with the half of the speed. So inner, can I say I am writing this speed in the upper crust and the lower crust? Upper mantle, asthenosphere, middle mantle and lower mantle. So यहाँ पे also the speed was maybe around 2.51 meters per second. यहाँ पे also the speed was somewhere around 3.5 meters per second. यहाँ पे also the speed was somewhere around 4.5 meters per second. But surprisingly, ये boundary line के बाद जो भी S waves थे, they could not pass through the core. And the last P wave, S waves that was recorded was at the boundary line of this black color. There was no S wave which could pass after this layer of the earth. That is, can I say they could not penetrate inside the core? And because they could not penetrate inside the core, and S waves की velocity is very, very less, P waves की velocity is very, very less here. So what we conclude? We conclude कि ये है liquid in nature. The outer core is liquid in nature. उसके बाद S waves again cannot pass through the outer core, so there is no question of S waves going inside the inner core. And as a result, but how then we conclude कि ये solid होगा? सबसे ज़्यादा P wave की speed किस में है? It is in the P waves. It is in the inner core, and therefore we can say it is the most densest. So S waves, when they are generated, they are not recorded in this entire region between this area, what is known as an shadow zone of an S waves. और अभी आपको समझ में आएगा why surface waves are not generated at all the places. क्यों? क्योंकि surface waves to be generated, there has to be interaction of P waves and S waves both with the surface rocks. यहाँ पे क्या है? यहाँ पे you can see the in this entire zone क्या होगा? S waves will not be there, and therefore यहाँ पे the surface waves will not be generated. There will be P waves in this region, but there won't be any kind of an S waves in this region. So based on this, why we say they are the best sources to study the interior of the earth? Because based on this, we divide the interior of the earth, the same diagram, on the basis of velocity into crust. And the crust is further divided into upper crust and the lower crust. उसके बाद then we call the next area as the mantle. And the mantle is further divided into upper mantle and the lower mantle. Upper mantle में the difference between the upper mantle and the lower mantle is this region. This is the upper mantle wala region, which is further divided into asthenosphere and the lower part of upper mantle. And then we have the lower mantle. And then the core is further divided into the outer core and the inner core. And based on this, we can understand that the outer core is liquid in nature. So this is how the P waves and the S waves will tell us. Why the shadow zones are created? The shadow zones are created because the S waves cannot pass through the liquid outer core. And why P wave का shadow zone is created? Because of the presence of liquid. Can you understand? इतना ज़्यादा refraction क्यों हो रहा है यहाँ पे? Because solid से it is going to the liquid medium, and liquid से again it is going to the solid medium, and therefore there is a large scale refraction. कभी भी होता है refraction in your real life also. अगर आप swimming pool के पास गए तो हमें ऐसा लगता है हमेशा कि swimming pool की depth is lesser as compared to the actual depth. Why? Because जो light waves है they bend, and as a result of this we find the depth of a swimming pool is lesser. Why they bend? Because they are going from air to liquid medium. Same, this waves are bending so much because they are going from solid medium to the liquid medium. So this is what is the regarding the interior of the earth. So don't draw this diagram. This diagram was just for your understanding. Yes. किसकी? P wave की. और S waves जाती ही नहीं है उससे. So उससे हमें proof है कि that is 100% liquid. See, this knowledge will change. Maybe if अगर ये knowledge wrong है तो this knowledge will change. But उसके लिए then we will have to go to the next level of scientific development. With the present scientific development and with the present evidences, this is the interior of the earth. Fine. But the knowledge will keep on changing many times. जैसे पिछले साल पता चला that there was one more continent जो अब समंदर के नीचे है, and उसके peaks are the islands of New Zealand. उसका highest mountains are the islands of New Zealand. बाकी पूरा that continent is below the sea level. अभी तक पता नहीं था. अभी तक हमें पता नहीं था जब तक भूज earthquake occurred कि इंडिया में भी peninsular इंडिया में भी there is a fault. So our knowledge keeps on changing, but with the present this is the interior of the earth. The interior of the earth is divided into crust. Crust is further divided into continental crust and the oceanic crust. Then the boundary line between the continental and the crust and the mantle is known as Moho discontinuity. What happens in the Moho discontinuity? There is sudden change of the velocity. This shows that the mantle is denser than the crust. The mantle is further divided into upper mantle and the lower mantle. In the uppermost part of upper mantle, up to the depth of 200 kilometers, is the zone of weak rocks, which is known as an asthenosphere. इसलिए ज़्यादा difference नहीं है velocities में. But the lower mantle is more denser, and therefore the P waves and S waves travel with the greater speed. There is again change in the velocity between mantle and core. This area is known as an Gutenberg discontinuity at the depth of 5,100 kilometers. Due to the absence of S waves, as the S waves cannot pass through the outer core and the P waves also pass through very, very low speed, therefore we can say that the outer core is liquid in nature. But due to the very, very high density of the inner core, we can, with the high speed of an P waves in the inner core, highest speed कहाँ पे है? In the inner core. We know that the inner core is solid in nature. अब Earth behaves like a magnet, not because of the presence of iron. Earth behaves like a magnet because Earth is an electromagnet. What do you mean by electromagnet? School days का याद करना. You take an iron bar, you wind a wire, pass an electric current. That iron bar will act as a magnet क्योंकि electric current है उसके आसपास. You stop the electric current, उसकी magnetic property is lost. Now what is happening कि ये outer core is liquid in nature, but ये liquid मतलब पानी नहीं है. These are minerals, and the earth is rotating with a great speed and also revolving. When the earth is rotating with the great speed, the minerals also start to rotate in the liquid form. जब कोई भी minerals या कोई भी liquids form में if there is a great displacement, तो there is a creation of charges. Positive charges and the negative charges are created. जैसे हवा जब बहुत ज़्यादा ऊपर नीचे जाती है with great speed, positive charges are created at the bottom near the earth and negative charges are created at the top. और फिर you see lightning, and this is what happens on the rotating earth. Due to the presence of liquid outer core, अगर solid होता core तो earth would not have been magnet. Due to the presence of liquid outer core, there is a creation of ions. This ions will give the magnetic field or magnetic property to the earth, and thus we have a huge magnetosphere of the earth. Earth if अगर stop होता है rotation, if earth stops rotating या earth की rotational speed कम हो जाती है, the earth will lose उसका magnetic property, and if the earth loses उसका magnetic property, what will happen? ये जितने भी satellites वो सब है वो फिर से they will fall down on the surface of the earth. It is, remember, the magnetosphere which is present on the earth because of the rotation that is saving us ourselves from very, very high velocity harmful solar radiation. Because solar radiation and the magnetosphere of the earth will interact, and when they interact, lights are generated on the surface, in the upper atmosphere, जो north pole and south pole में दिखता है. Why? Because the magnetic field सबसे ज़्यादा strong कहाँ पे है? In the polar region. जैसे you have seen, magnet का भी सबसे stronger parts are poles. So when the solar radiation, solar currents come inside the earth, they interact with the magnetic field which shields the earth, and thus there is an current like thing जो हम कहेंगे aurora borealis and aurora australis, northern and the southern lights. But कभी कभी ये magnetic field, we do not know why, becomes weak, and sometimes the solar winds will come and enter the surface of the earth, and उस समय, just like last year or last to last year, governments will be worried because if the solar wind comes in the earth, ये जितना भी हमारा electronic system है, it can destroy this electronic systems. Because you see, अगर earth का magnetic field बंद हो गया, so there will be no communication, no satellites, no electronic systems, because then the solar radiations will come and hit the earth and life will not be possible on the earth. इतना highly charged radiations है वो, that they will kill everything on the earth. That is why I said everything is a manifestation of an energy and everything is relative. Why everything is relative? Because for us maybe the earth is the only planet with life, but we do not know how many planets are there like earth in this entire solar system. For us, we think that we are the most intelligent people, but we do not know कि हम भी किसी की case studies है क्या. That is, there will be a very big universe and somebody is watching us कि ये क्या कर रहे हैं. Just like we keep the rats in the laboratory and watch them, and rat को लगता है ये उसका पूरा life है. So we also do not know, and therefore comes the concept of parallel universe वाला concept. We'll do that later on, parallel universe, because ये सब metaphysics है. That is, we do not know कि सच है कि नहीं, but what we know one simple thing, कि जहाँ पे science ends, what starts? Religion starts. जहाँ पे the boundary of science ends, वहाँ पे the religious belief starts. और ये religious belief का जो boundary है वो छोटा छोटा हो रहा है if you prove it by logic. जहाँ logic खत्म हो जाता है वहाँ पे भगवान, जहाँ पे logic आता है वहाँ पे भगवान नहीं, and everything cannot be explained by logic. So with this background, now just remember there are basically two kinds of, what is the layered structure of the interior of the earth? Crust, mantle and core. Why we know so properly that earth is divided into different layers? Because of the change in the direction and the velocity of P waves and S waves. By the change in the direction you can conclude what it is made up of different densities, and कौन सा layer कितना dense है, that is told by the velocity of the P waves and S waves. उसका state of the matter, whether it is solid or liquid, it is again told by the P waves and S waves, because S waves does not pass through the liquid outer core. So,
you told us about the electromagnetic character of the earth. So it is just because the earth is rotating, so the liquid part है वो उसमें displacement हो रही है.
yes, yes, liquid part is also rotating, और जब भी liquid part rotate होता है तो charged particles form होते हैं. Due to charge, electric currents are generated, and due to electric current on any rotating surface, magnetic field is created. Because earth में सबसे ज़्यादा iron ही है. अर्थ का crust छोड़ा तो बाकी पूरे अर्थ में most dominant mineral is iron. and thus we take an example of an iron bar and uske baad we have an electric current. So same thing is happening to the earth. Earth is also an electromagnet. Earth is not just magnet, it is an electromagnet. We know that most of the earth is made up of iron. We know that the most dominant mineral is iron. Metals हम नहीं कह सकते, हम सिर्फ minerals predict कर सकते हैं. Metals predict करना possible नहीं है, because वही you said कि minerals बता सकते हैं हम कि ये mineral हो सकता है, but it may not be always true or correct. इसीलिए तो कभी कभी exploration fail हो जाता है कि हमें लगता है कि यहाँ पे XYZ mineral मिलेगा, we dig up and वहाँ पे mineral मिलता नहीं. For example, Geological Survey of India thought कि India has the largest deposits of uranium, पर वैसे हुआ नहीं. So that is, you cannot predict the metal, you can predict only mineral. Metal prediction के लिए तो वहाँ पे survey करना पड़ेगा and dig up करना पड़ेगा, and जो impossible है. So take down the next point. The property of S waves, that it cannot pass through liquid, helps us in understanding that outer core is liquid in nature. Because the S waves do not pass through the outer core. S waves do not pass through the outer core. And hence the shadow zone of an S wave is greater than the shadow zone of an P wave. And hence the shadow zone of an S wave is greater than the shadow zone of a P wave. So just can take this diagram. You can use the stencil in the examination to draw the diagrams, गोल वाली. India map वाली stencil is not allowed at many centers. Have you finished drawing this diagram? इनके ये डायग्राम तभी जब उन्होंने पूछा एक्सप्लेन द इंटीरियर ऑफ द अर्थ विद द हेल्प ऑफ seismic views. But if the question is interior of the earth, write a short note on the interior of the earth, or the interior of the earth with the recent views regarding the interior of the earth, then you should make the diagram which we are drawing now. Can I rub this diagram? So this diagram is nothing but a cross-sectional view of the earth. That is taking this cross-sectional view. So headline interior of the earth, proper detailed diagram. So and this is what the diagram is. So what does this mean? Sea. That is the this is the continental crust and this is the oceanic crust. टेम्परेचर इंक्रीज होगा तो लिक्विड इसलिए क्योंकि वहाँ पे टेम्परेचर इंक्रीज ज़्यादा है एज कम्पेयर टू द डेंसिटी. सो इट ऑल डिपेंड्स अपॉन नीचे जाते जाते टेम्परेचर भी इंक्रीज हो रहा है, डेंसिटी भी इंक्रीज हो रहा है. सो व्हेन temperature increase is dominant as compared to the increase of density, liquid. If the density का increase is dominant as compared to the temperature, then solid. State of matter it depends upon कितना temperature है और कितना density है. यहाँ पे temperature बहुत ज़्यादा है, density relatively कम है. क्यों कम है? Because ऊपर है ना ये, core में बहुत ज़्यादा temperatures है, so पूरा core liquid होना चाहिए. बट क्यों आउटर कोर लिक्विड है और इनर कोर क्यों नहीं है लिक्विड? बिकॉज आफ्टर 5000 किलोमीटर्स डेंसिटी इतनी ज़्यादा बढ़ गई कि ये सॉलिडिफाई हो गया. प्रेशर प्रेशर अपर का प्रेशर. हाँ तो मैंटल भी सॉलिड है. इसी इट ऑल डिपेंड्स अपॉन द कॉन्स्टिट्यूएंट मटेरियल. रॉक्स रॉक्स कौन से मेल्ट होंगे और कौन से नहीं. हाँ सो रॉक्स भी तो अलग है. So it all depends upon the कौन सा rocks है. Iron will not melt that easily, but if the rock is something else, it will easily melt. मतलब हाँ तो core ही है. क्या हुआ? Core is made up of different material from mantle. Mantle is made up of different material from crust. Temperature, density, and material. मिनरल्स कौन से? यस दैट इज वाई लिक्विड. सो दिस इज द 3 layered structure of the interior of the earth. Up between crust and mantle. Between crust and mantle, not between oceanic crust and asthenosphere. Between the crust and the mantle. No, क्योंकि ये तो बाउंड्री लाइन है. क्रस्ट और मैंटल की बाउंड्री लाइन है. एस्थेनोस्फीयर मैंने इसलिए ऐसे लिखा है दैट यू शुड नो इट इज एन पार्ट ऑफ अपर मैंटल. इसलिए आई हैव रिटन इट दिस वे. एस्थेनोस्फीयर इज एन पार्ट ऑफ अपर मैंटल. फिर अपर मोस्ट मैंटल, अपर मोस्ट पार्ट ऑफ एस्थेनोस्फीयर and crust, इसको हम प्लेट टेक्टोनिक्स में कहेंगे as lithosphere. That is a different thing. So take down the crust. Crust it is the uppermost part. It is the uppermost part. It is divided into the continental crust and the oceanic crust. It is divided into the continental crust and the oceanic crust. It is divided into the continental crust and oceanic crust. Continental crust is composed of lighter minerals or materials. It is composed of lighter minerals or materials such as what? Silica and aluminum. Such as silica and aluminum. Silica and aluminum. It is an average thickness of around 35 kilometers. It is an average thickness of 35 kilometers. Average thickness of 35 kilometers. ये asthenosphere क्या है? Can I say this is nothing but magma? So जितना thick है crust उतना there is a less chance of volcanic eruption because magma फिर easily ऊपर नहीं आएगा. जितना thin है crust उतना there is a greater chance of volcanic eruptions. Now, where will be the crust very thick? On the plains or below mountains? Below mountains. So, which are the highest mountains in the world? Himalayas. So, below the Himalayas, the thickness of the crust is 70 kilometers. Average कितना है? 35. Himalayas के आसपास कितना है? 70 kilometers. And therefore, Himalayas are the only fold mountains in the world which do not have volcanoes. Remember why? Because the crust is so thick that it cannot escape the magma cannot escape and cannot cause an volcanic eruptions. So, you can take down one line there. Below the high mountains, the crust is very thick. Crust is very thick. Bracket में लिखना only for prelims the next line. Himalayas experience doubling of Earth's crust. Doubling of Earth's crust, and hence there is absence of volcanoes. Himalayas experience the doubling of Earth's crust, and hence there is an absence of volcanoes. Bracket closed. Which is the most common rock in the continental crust? Granitic rock is the most common rock in the continental crust. Granitic rock is the most common rock in the continental crust. Oceanic crust. It is made up of rocks of higher density. Example, basalt. Its average thickness is 5 kilometers. Its average thickness is 5 kilometers. It can be 0 kilometers also at some places, but उसका average thickness is somewhere around 5 kilometers. So इसीलिए आगे जाके आप देखेंगे कि volcanic eruptions कहाँ पे common होंगे? Below the sea. That is why sea floor spreading. Take down one more statement. It is dominated by silica, magnesium and iron. The crust mantle boundary is known as Moho discontinuity. The crust mantle boundary is known as Moho discontinuity. Fine with this? We'll continue tomorrow. You have a test now. So